Hi, I'm Mike. This was originally going to be titled Corporate Politics and Security for IPv6 world, but it seemed boring and misleading, so I've changed that to Is IPv6 better for network security? And there's still a little bit of the corporate stuff in there, of things I wanted to do that I couldn't do. I started off as a junior engineer in the UK, and I said, why don't we move to IPv6? And at the time, the team in the UK weren't keen on IPv6, so that didn't happen. And I've carried that theme on as I've moved around. So I was told I'm allowed one slide of my company logo, but we have quite a few. So I work for Liberty Global, but we operate in other countries. So in the UK, we're Virgin Media. Here, we're Vodafone Ziggo, and we have Telnet in Belgium and various other names. And in some of them, we don't do so much IPv6, and I'd like that to change. And that was kind of the underlying statement here, and we should acknowledge our biases, I guess. I wrote this as an internal memo with the aim of convincing people to move to IPv6. So I think everyone should be familiar with what IPv6 is, and high level, I'll just quickly cover off here. There's two charts. So on the left, we've got Google's IPv6 usage. So this is based on consumers going to Google. That's YouTube and Google searches. And they're saying they see around 40 to 45% of the traffic coming to them is IPv6. On the right, there's slightly different numbers. This is from Jeff Houston at AP Labs. And he's seeing slightly lower numbers. He's saying 30 to 35. I talked to him about this. He said the difference, he thinks, is because he's also querying China, whereas obviously Google maybe doesn't have so many customers in China. So there's a 10% difference. He's saying it's probably related to China. But I think we can all agree 30 to 45% IPv6 usage globally seems like a good number. So 6830 is a tier 1 ISP, which means we get a really good perspective of a lot of the traffic going through the UK, through Europe. Okay, yeah. Yeah, a bit funny. Okay. It looks better for me. But yeah, so we get a good view of what's going on through Europe. A lot of networks and a lot of traffic users are tier 1, so whoever your home residential provider is, there's a fair chance that it's going to cross our network at some point. And that gives us a really good insight and a really good bit of visibility. And then it's only fair to show our internal numbers of what we see. So these are the countries we have operations in. We also operate in other countries, but these are where our major eyeballs are. And we can see a fair number of IPv6. We're kind of slightly below what Jeff sees, but we're there. In most countries, there's maybe one outlier. And then moving on to DDoS mitigation. So we offer this to our customers if they want it, if they'll pay for it. On the left, I don't know how clearly you can see it here. On the left one, we've got a V4. It's a DNS-based amplification DDoS. So it's about 20 gig of traffic going to a single /32 address. It's quite a lot. If it's a small business, that'll probably overload them. And we have the ability to just scrape off anything we think is a DDoS and only send valid traffic. So we do a bit of anomaly detection, and we say that seems weird. They've got a lot of DNS requests coming from Russia. Probably don't want that. We'll take it away. And on the right, we've got something similar for IPv6. It's a /128, so again, a single IP address. This is not so big. It's smaller packets, but it's the same thing. And it happens in both IPv4 and IPv6. We see it happening in both, and we can mitigate for both as well. And I was looking at this a while ago, and I got thinking, I see a lot more come through in IPv4, and I see a lot less in IPv6. There are some DDoSes in IPv6, but there's a lot less. And I wanted to try and understand what that difference was. So I went through and I queried our results, and I got the results for the year of 2022, and these are the differences. So this is a linear chart. So in blue, we've got the IPv4 DDoS attacks, and in green, the IPv6 DDoS attacks. It's quite different. We see about 100 times more IPv4 attacks than IPv6. That makes about 1% of the attacks are IPv6. Now, we saw earlier, and I think we all agreed, 30 to 45% globally of the traffic we're seeing is IPv6. Is it unreasonable to expect a similar number? I don't know. But we're seeing a lot less DDoS attacks on IPv6. That could be the end of the presentation. But then I started wondering why that was, and I wanted to dig into it a little bit. So I came up with a few avenues and ideas I wanted to look into. I've got some here. So first of all, a lot of the DDoS attacks we see are botnets. So this is a bit of malicious software that's installed maybe on your laptop at home, and it sits there, it reaches out to a command and control system, it gets guidance on where it should attack, and it kicks up, it starts running, and it executes and it targets the system. A lot of malware like this is, well, there are trade-offs to be made. So size and complexity are traded off against detectability. So the bigger it is and the longer it takes to run, the more likely it is that antivirus will pick it up or something else will see it. So a lot of these programs will try and be as small as they can and use common APIs to avoid detection. The example here is Mirai. It's a Linux-based bit of malware. It's a DDoS bot. And I don't know how clear it is on the screen, so it's identifying in the middle there IPv6 indicators. And we looked into it, and on the right there, we've got the list of the IOCs. So these are the addresses that were found. Now, I don't know how clear it is, but when I looked at that, I didn't see any IPv6 addresses. I only saw IPv4. But I wanted to look into it in a bit more detail. So I was told not to do any live demos, but I'm going to give it a go. I've got backup slides if not. Oh, indeed. So I've downloaded a smaller, simpler bit of malware from Malware Bazaar. You can pull whatever you want, really. And I've copied it already, and I've got it here. So I'm going to take this to the first line to start with. Maybe. And I've got a PowerShell window open already, and I ran a get variables just to show at the top. The system variables are set. I haven't run anything yet, so it should be good to go. This is the first line. It doesn't show so well on the screen, but it's a lot of variables with blank spaces. It doesn't really say what it's going to do. We can run it. Didn't do anything. So you can see here the environmental variables have changed. We've got a number of variables that have got names there that are just blank spaces, and they have values. So that seems pretty harmless. It's just set some blank variables. Okay. Then I've got the second line. I'm going to be careful here not to get the pipe at the end. That's going to execute the code, and I don't want to do that. There we go. You can see it, it's just more blank variables. And then when I run it, it converts all those blank variables, so that was obfuscated code. Now it's saying we've got a ton of chars, so it's converted those to chars, but it's still pretty meaningless. I struggle to copy and paste this next bit, so I'm going to... It's the same code. I just pre-did it 4 or 5 times beforehand to make sure it would work. So when I paste that in... Crap, okay. Right. Yeah, so I prepared some backup slides. Here's the same code. Oh, it's bigger. Maybe that's better to see. So at the end, I just miss out the pipe in the execution, and it runs and it compiles to this. This is a PowerShell script, so it's slightly different. But the key bit here is on the fourth line down, you've got a URL there. So that's an IPv4 address, clearly. So that's hard-coded in. And if someone was to look at this and report the indicators, what they're going to say is they're going to say, hey, we see this bit of malware, and we see it's only got an IPv4 address. Clear. OK, case closed. If we look a little bit further down, it's client new object, and then it calls system.net web client. So that's the Windows framework. Now, Windows as an operating system is dual stack. So if this is in a laptop at home running on Windows, and if that laptop at home has a residential connection, and most residential connections in this country, the Netherlands, have dual stack IPv6, this could still be used, even though it's only got a IPv4 address as the command and control system. This could still be used for an IPv6-based DDoS attack. So the malware, when I looked at this, we started to think we were on a line, and then we realized this isn't an indicator. This doesn't tell us that we can't do IPv6-based DDoS attacks. And I went a little bit further, and this is I've got an example here from a friend, Pavel. He's tried to install a new computer using only IPv6. He had a few issues with genuine software, and he said, hey, I can't get everything working, and Spotify here was his example. And I don't program in Go, but I read a blog that said in Go you've got two different, and I'm looking for Ben to nod here when I say this, you've got two different frameworks. You've got net.ip and netaddress.ip, depending on if you're, maybe I'm not true. Sure, okay. There we go, I was right. So what I came to realize is some bits of software do support IPv6, some don't. And if we go back to saying about needing to duplicate code and keeping code as small as you can, potentially you're going to be in a situation where you can't use system libraries and you've got to double your code base, which isn't good. It's going to make the malware easier to detect, which isn't good. But on the whole, we can't really say that malware doesn't support IPv6. So that's not something I'm going to come up here and say. I'm explicitly not going to say malware doesn't support IPv6. It does. But I'm still going to say there's a lot less IPv6 DDoS attacks. So where can I go from here? Another way that DDoS attacks happen is with spoofed source addresses. So this is when, in this example, we've got at the bottom, a AS65536. They run an open resolver. They want to answer some queries. And they expect queries to come from Contoso on the right here. And any queries they get to Contoso, they're going to happily answer. What they don't account for is Fabricum on the left here, sending them some other queries, but pretending to be Contoso. So they're going to send their replies to Contoso, probably amplified. This would be a spoofed attack. So we get bad traffic coming in on the left, getting amplified and getting sent to a genuine source. And this happens. We see this quite a lot. And as a tier 1, we're able to work with other tier 1s and also some of the CDNs. And we can see where this happens, and we can trace this kind of stuff back. In this example, one hop, we could say we can see the bad traffic coming into the network from Fabricum, and we should see it should be coming from Contoso. But we can do this globally. We can work with other providers, and we can trace things around the world. So we do that. And if we see something that doesn't look right, we can trace it back, and we can find where it comes from. And that was another factor. So I started looking into this a little bit. And this is one of the reports we've generated. I've left the names in. It's factual. This is an average week. This was in September. And we saw all of these DDoS attacks on the left coming in. So I'll call out, there's 2 government ISPs. We've already highlighted that China's potentially partly the reason that Jeff sees a 10% difference in IPv6 usage. So maybe some of the government ISPs we see that are involved in this kind of stuff are focusing more on IPv4. Maybe that's a factor. We then looked at some of the providers. So these are VPS providers. And we're thinking here again, if you're a bad actor and you want to get access to a server, you want to do something bad on it, you're aware that if you get caught, it's going to get taken off you. So you don't want to spend too much money, and you don't want it to be traced back to you. So then I looked at what I could buy anonymously and cheaply. And on the right is just a print screen from a VPS seller. So I found I could sell for 40 euros, I could buy a server. But the base models, the cheapest ones available to me, only have IPv4. So I don't know if you can see, it's a little bit blurry, but they only have IPv4. And that's very different to, I think, what Amazon's doing now, where they're charging for IPv4, and you only get IPv6 for free. And I'll call out as well, Amazon do a great job making sure there's no spoof traffic on the network. And When they see DDoSes, they're very good at blocking it. They're very responsive to us. We're happy. But this other provider, they're providing IPv4-based VPSs, and we see them on our reports, and that's not nice. So here's another option. Perhaps the sources of DDoS attacks and where they're originating from, perhaps they only support IPv4, and maybe that's why we're seeing more traffic coming through on IPv4. Another idea I had was maybe a knowledge gap. I looked at the CCNA modules, and I can tell you in there's a little mention of IPv6, but it's more of a ticking the box exercise. They switch straight back to IPv4. And I think that's true for a lot of things. There's probably a bit of a knowledge gap where you learn IPv4 first, you can go ahead and start working, and there's no need necessarily to learn IPv6, because everything just works in IPv4 for now. So I called that out as another factor. And then finally, I've got the big one. I think this is probably the one that everyone sit there going, oh, has he not seen this yet? Yeah. IPv6 space is way bigger than IPv4, and it's not possible to scan. So there's an example here that says exactly the opposite, IPv6 scanning world, and I think this was Shadow Server who said they were able to scan some of the IPv6 space, which is great. But the truth is that every residential customer has a /56 assigned to them. That's more address space the entire IPv4 pool. That's not something that anyone can scan. So I think quite reasonably you could sit at home with an IPv6 server open with whatever ports you wanted. No one's going to find it, and no one's going to be able to compromise it. I think it's very unlikely. There's a bit of security through obscurity here. And I can put my word to that. I've got a VPS that I just saw running. That's open on IPv6, and it's not been compromised since I set it up yesterday night. Yet. That's not a challenge. So then we looked at other things. So we also get abuse reports. So I've got some examples here coming in, going in to us. These are public information feeds. So Shadow Server runs a really good one, and some other teams as well. And they'll scan the internet, and in IPv4 world, they do this really well, and they say, hey, we found these ports open, and if it's one of our customers, we can write them a nice letter, we post it out to them, hey, you've got this port open, we think it's open to abuse, you might want to close it down. I should note here, we don't scan our own customers' ports, and we don't scan traffic. These are public feeds that everyone can access. And then finally, at the bottom, I've got an IPv4 scan. So we do vulnerability scanning, and we do this in our enterprise situations, but it's quite slow. This was scanning 50 IPv4 addresses, and it took 20 minutes. Imagine trying to do that for, 360 undecillion addresses? It's not going to happen. So at the end of the day, I'm kind of saying there's a bit of security through obscurity. Attackers are currently focusing on IPv4, but they're fully capable of reaching IPv6 if they want to. And when we look at it, what would an attacker gain from focusing solely on IPv6? Very little, because everyone's dual stack or IPv4 only. They aren't going to find many new targets. But there are a few IPv6 attacks out there. And we do think IPv6 attacks are going to increase as time goes on. Oh, I'm out of time. But it won't be easy to identify compromised devices. I've got one more slide. Can I go? Okay, I skipped that one. And this was an enterprise vulnerabilities view. So we sat down with our corporate enterprise teams, and this is not for our customers, this is for our internal stuff. We wanted to know what we could scan and what we weren't scanning. So we looked at what we knew. We knew our server configs and our router configs and our domain names, and we can pull these and we can make sure we're scanning all of our own systems. We know our prefixes, and we know what hardware we're running, so we can guess the addresses there. And we also run our own firewalls and routers, and we can look at the logs and make sure we're scanning anything there as well. But what we can't do is we can't scan all of the address space we have. We can only scan what we know we're using. We came up with a few examples what enterprises could do. You could scan your Slack addresses or IPv4-based addresses, and on a single LAN, you could do some multicast scanning and DNS-based scanning. But I leave it with a question from me to you, actually. What could we do to scan more IPv6 address space and better protect our customers?
Right. Well, Does anybody have the answer to that? Not yet. I would like to bring to the table, you mentioned that hackers don't have anything to gain by using IPv6. But I would like to bring to the table that I think that many firewalls are not configured for IPv6 at all and will just pass it. They might have elaborate IPv4 rules, but nobody ever thought of v6. I don't want to bring any inspiration to any aspiring hackers in the room or indeed on the stream, but I think it might be easier to compromise a host over v6 than it would be over v4. But who knows? We have time for a question.
Hi, you showed the provider Hetzner online. They're dedicated servers, but you call them VPSs. They actually have dedicated servers, and they do have IPv6. Now, IPv4 is just laid out because they charge extra for it. So it's like a feature they have, but you can pay less if you want IPv6 only. So you actually get a /64 that you can do stuff with.
So these servers do have IPv6?
Yeah.
My mistake then.
They do have VPSs, which are even cheaper. So in theory, those could be used maliciously for very little money.
Good. Good to hear. Thank you, Michael. We have a present for you. Hang on. We would like to say thank you.